Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them. And then with each lesson, there will always be a document which covers whatever has been done in the lesson. So you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson. In the last lesson, I talked to you about the shape of a quadratic, the discriminant, and how b squared minus 4ac helps you figure out what kind of roots the equation has. But that's not just the only job of b squared minus 4ac. In fact, it's very useful to decide so many things about intersection of a line and a curve, or maybe later on under what conditions does a line will be tangent to a parabola, tangent to a hyperbola, tangent to an ellipse. So there are varied uses, and later on you can see if there are any real solutions of an equation. So the concept of discriminant is very useful. Again, let's be careful, you've got a discriminant of a cubic as well. So we're only talking of discriminant of a quadratic, we're not going beyond. So to recollect, so we will look at today, the topic is still, we are in basic algebra. I think it's going to go on for the next 6-7 more lessons apart from this. Topic is basic algebra. And then today we're going to learn about applications of discriminant. Of a quadratic. As usual, you don't have to copy anything, listen to me, and then later on you'll get the handout along with the video, so you'll be able to download and use it. Let's take a simple example. Show that this we use for minimum or maximum at times. You could do it this way as well. Show that 2x squared minus 3x plus 7 2x squared minus 3x plus 7 greater than 0 for all x belonging to R. 3 marks, but more than 3 marks. Now we need to analyze. This is a quadratic function. I must show that it is always positive. Remember, the shape of a quadratic, if a is greater than 0, would be like this, and if a is less than 0, would be like this. And you know, purposely I have drawn that diagram so that I can tell you why. Positive means whatever x might be, the graph is above the x-axis. So it's a U-shaped graph. This is your analysis. You don't have to write it in the exam. It's a U-shaped graph, U-shaped parabola, of course. A U-shaped curve does not cut x-axis. That's the information you have. So if it does not cut x-axis, it doesn't have any roots. Real roots. If it doesn't have real roots, your discriminant must be negative. So in other words, show b squared minus 4ac is less than 0. So we just do it there. So b squared, a equal to 2, b equal to minus 3, c equal to 7, b squared minus 4ac will be 9 minus 4 times 2 times 7. You don't even have to evaluate it. It's 9 minus 4 times 2 times 7 automatically is less than 0. And a equal to 2 greater than 0. So from these two we can conclude it does not cut the x-axis, it's a U-shaped graph or has a minimum, so therefore it's always positive. So how do you write the solution in the exam? Very simple, you don't have to write any of these things. I'm just showing for them. From the next example, I won't write all this, I'll just talk to you. I thought since this was the first example, I would show you. So in the exam, what you write is very simple. You say a equal to 2 greater than 0, b squared minus 4ac equal to minus 3 squared minus 4 times 2 times 7 less than 0. Therefore, 2x squared minus 3x plus 7 is always positive. That is sufficient to conclude that. That's all you write in the exam. But I went through the logic to show you how you write it. Let's take another example. The other example would be, after that, to make up all these examples, find the set of values of k, find the set. This is a typical AS level sometime now in your paper 1, since you have 2 A-level papers in math, pure math, it will come in one of them. Find the set of values of k for which the equation x squared minus k minus 8 times x plus 11 minus k equal to 0 has real distinct roots. Again, the analysis here. You have been told the equation has real distinct roots and it's a quadratic. So that means mentally you realize your graph is like that. It's a U shape because x squared is positive there. The coefficient of x squared is positive. So therefore, that means it has 2 real roots. For it to have 2 real roots, b squared minus 4ac, the discriminant must be positive. So real, this is what you write in the exam. Real and distinct roots. Means b squared minus 4ac greater than 0. So your a is 1, b is minus of k minus 8, c is 11 minus k. So put in the values. B squared, we can ignore the negative sign, minus 4 times 1 times 11 minus k greater than 0. Expand this. K squared minus 16k plus 64 minus 44 plus 4k. Please be careful. It's not a minus 4k. In a hurry, I've seen students writing a minus 4k and getting into a mess. So therefore, I get k squared minus 12k plus 20 greater than 0. That's the reason why before I started this, I taught you how to solve inequalities. This is a quadratic inequality. So what the first thing you do? Find the critical values. So put k squared minus 12k plus 20 equal to 0. Show the factors k minus 10 and k minus 2 is 0. So k equal to 10, k equal to 2. Those are the critical values. Yeah. and then draw a number line, mark the critical values. It's a U-shaped graph, and I want it to be positive. It is positive there, it is positive there. So k less than 2 or k greater than 10. Or you can say k less than 2, comma, k greater than 10. But the exact answer would be k less than 2 union k greater than 10. So that is the second application of discriminant, how you use it. There is one more. For example, these are various applications. Even though the topic is just quadratic equations, they can ask so many different types of questions, and there is no way I can exhaust all possibilities. I'm just giving a bit of example here and a bit of example there, in the hope that you remember at least some of these methods. Find the values of m for which y equal to mx is a tangent to the curve. Again, I'm sticking to quadratic at the moment because otherwise we'll have to use some other method we will see later. To the curve y equal to x squared minus 6x plus 8. I can take any value or just take an 8. I've made up these questions. So in other words, look, this graph is like this. 4 and 2. Y equal to mx is a line like that. See this line? Y equal to mx is a line like that. So now you're asked to find what is the value of m for which it could be a tangent. That line cannot be a tangent, right? But this could be a tangent. Yeah? That could be a tangent. A line passing through origin and being a tangent to the curve. So mathematically what we do is the gradient obviously will have to be negative, not positive. Or it could be positive as well. I'll show you how. Maybe if I would draw a nice graph like that, I could have a tangent like this. It can't have a positive gradient obviously from the diagram. So, you see, I could have a line like that. I could have a line like that. Yeah. Those two lines would obviously be tangent to that curve. So there are some values of m. So my job is to find those values of m. That's again the theory. The examiner doesn't expect you to draw sheet and figure out. Very simple. Therefore, this line. So again, going back to the analysis, if you have a quadratic, if you have a line, the line might cut in one, or it might be like this, or the line might be somewhere like that. So the line intersection curve, 2 points, or 1 point, or no point. Remember, that's when you put them together, it's a quadratic. So looking at two solutions of a quadratic, one solution only for the quadratic, no solution. That's going back to your discriminant. Real and distinct roots, equal roots, imaginary roots. So now in this question, I want it to be a tangent. That means I don't want that. I don't want that. I want only that. So therefore, if you solve them simultaneously, I need to have only one solution. So what I'll do is, so let us solve simultaneously. So x squared minus 6x plus 8 equal to mx. Therefore, arrange it as a quadratic equation. Remember, you always have, so everything on one side, which I could write as x squared minus 6 plus m times x plus 8 equal to 0. That's a quadratic, has only one solution. Remember, when we discussed, I told you it's a quadratic, it has to have two solutions. But I'm saying only one, meaning, which means it has equal roots. If it has equal roots, that means b squared minus 4ac must be 0. So a is 1, b is minus of 6 plus m, c is 8. So b squared minus 4ac. Now here is again, you can use your brains. Majority of the students will expand this. Let's do the expansion. Only then you'll appreciate what I'm talking of. So you get m squared plus 12m plus 36 minus 32 equals 0. You get m squared plus 12m plus 4 equal to 0. Obviously, you can't factorize. So a equal to 1, b equal to 12, c equal to 4. So I would do m equal to minus b, which is minus 12, plus minus square root of b squared. B squared is 144 minus 4ac will be 16 divided by 2a is 2. So a squared minus b plus minus of b squared is, have I read it correctly? Yeah, 6 2s are 12, 36 minus 4, 32 is 4, yeah. So b squared is 144 minus 4ac is 16. 144 minus 16 is 128. And remember, I haven't taught you search, but I expect you to know from GCSE is 64 times 2, which is 8 root 2. So it is minus 12 plus minus 8 root 2 over 2, divide through by 2. So I get minus 6 plus minus 4 root 2. Right? That's the answer. Let me write the answer here for my reference, so that I have to rub it off because I have a space on the board. But for us to remember, I'll write that answer here. M equal to minus 6 plus minus 4 root 2. Now, let me show you something interesting. At this stage, this is where at A level, you need to learn to think a bit. Look, instead of doing this, can I say, I'll use a different color so you understand. 6 plus m whole squared equal to 32, which is 16 times 2. So 6 plus m equal to plus minus root 16 times root 2. Oh, this pen is giving up, sorry. So therefore, 6 plus m equal to plus minus 4 root 2. So m equal to minus 6 plus minus 4 root 2. So why waste time doing all that quadratic equation, formula, everything? Whenever it is a square and a number, for heaven's sake, take the numbers to the other side, take square roots. But remember, this is a common error again. If the question says root x, and if x is 4, your answer is only 2. Because it's assumed when you're given root x, root 4 is 2. So root 4 equals 2. Whereas if you're solving x squared equal to 4, x will be plus minus root 4, which is plus minus 2. That means if the question gives a root, it's always a positive root. But if you are taking a root by taking a square root of a square, you have to consider both plus and minus. So don't forget here, you must have plus minus, because even otherwise, you should remember quadratic equation, a quadratic equation in m squared, it's a quadratic, So I must have two values of m. And this doesn't have equal roots. That equation has equal roots. Even that equation doesn't have equal roots. So you need to be careful where you're applying the discriminant. So I've just taken some examples to show you how to do it. And so next time I will talk about, to be honest, I don't know whether I should do a short lesson on surds and indices just for your reference. But all that has been taught in GCSE. And at A level, I don't think I should be doing that. Let's do like this. I think you people are all clever enough to deal with surds on your own. So I'm not going to do that. So from here, I'll jump to remainder and factor theorem. And then from there to curve sketching and so on. Okay? So that will be in the next lesson. Thank you very much. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.